What's up guys, Coach Slinger here. Hope you're having a wonderful day. If not, then go make an app. It'll make you feel better. Today we're going to look at stacks. So before we start, you do need a basic foundation of your preferred programming language to follow along this video. We'll be using JavaScript. Even though the syntax will be different, the basic implementation will still be the same for most programming languages. So let's look at an overview for our video. If you don't want to watch the full video, I'll include timestamps in the description for the different parts. So first we're going to look at some slides. Then I'm going to show you a basic stack implementation. And then we're going to look at some examples of how you would use stacks and why you would use stacks. And then lastly, I'll show you a tiny project that I made. And I highly encourage you to play around with the stack and make your own projects, as that is the best way to learn. So what is a stack? Well, the word stack should tell you by itself. It's stacking objects on top of each other, like books. Or you can think of it like loading bullets into a magazine. The last bullet that gets loaded into the gun will be the first one that gets fired. And the first bullet that gets loaded in will be the last bullet that gets fired. That's a horrible analogy, but please don't shoot me. So a stack is an example of a LIFO structure, which stands for last in, first out. And as it says, the last object that gets added to our stack will be the first one that gets removed. So let's look at some pictures. Here we have a stack with two objects in it, a green object and a blue object. If we want to add a new object, we can only add it to the top and not in between blue and green or below green. So if you want to add pink, we have to add it to the top. Our stack will look like this. So what if you want to remove an element? Well, naturally, you can only remove from the top. So if you want to remove blue, you'd have to remove pink first, and then you can have access to blue. Okay, so we know what a stack is, but what would you use it for? One such use case is backtracking problems. You can think of this when you use Ctrl-Z to undo a previous action. Whenever a program implements such a function, it stores all of your actions in a stack. So every action gets put onto the stack with the latest action being on top. If you ever made a mistake, actions can be removed from the stack, so your latest action will be removed first and you can go all the way back to the part that you want to fix. This is the easiest example of backtracking problems. Another use case is memory management. As this is a bit hard to explain with just theory, I'm going to explain memory management later when we use an example. Another use case is expression evaluation. So in math, you have an order in which your expressions should be calculated. Parentheses will be calculated first, followed by multiplication and division. And then lastly, you'll do subtraction and addition. You can use a stack to store the different actions in different segments of your stack. So parentheses will be executed first, so you can put that in your stack up to the last execution of your expression. Palindromes aren't really useful in real life, but they're great for showing how a stack really works. So we'll look at how to implement a stack using palindromes. Factorials are also another niche use case, but there are situations where you might use it, and a factorial will be great for explaining why a stack implementation would be a better solution over others. If you don't know what a factorial is, it's basically when you multiply a number by all numbers preceding that number all the way up to 1. Okay, so what do you need? Well, not you, but for the stack. First, we need some kind of box or container for our stack elements. Then we need a way to keep track of those elements. And lastly, we need a way to manipulate our stack. So we're going to make custom methods that will allow us to manipulate our stack. So let's look at a few methods you can use in our stack. The first being a way to add elements to our stack. And obviously, if you want to add elements, you also want to remove those elements. So we need a remove function to remove those elements. We also want a peek method so we can have access to whichever element is at the top of our stack. And we need some way to erase our stack or reset it. So we'll use the clear method to reset our stack. We also need an amount function which will give us how many elements are in our stack. Notice that amount doesn't have parentheses. That's because later when we implement the stack, we're not going to implement our amount method as a traditional method. We're going to call it as a property using the get keyword. And that's the end of this slide. Okay, so now let's jump into our favorite code editor. Okay guys, now that we're in our favorite code editor, we can start implementing our stack data structure. So you can create a folder, you can call it whatever you want. I called my folder code, and in that folder you can create a file related to whatever programming language you're going to use. I'm using JavaScript, so I created a file called stack.js. Okay, so now we're going to use ES6 syntax to create our stack data structure. So the class syntax in ES6 for JavaScript creates a blueprint, and every time we instantiate a new object, that object will follow this blueprint. So it'll have access to all the methods and properties we're going to define in our stack class. So we just say class, give it a name, and there we have our stack data structure. Thanks for watching. Just kidding. So now we need to construct our box or container in which our elements will go into. So we can use a constructor function to create our box. We also need to use the this keyword and then the name of our box. I'm going to call it stack container. And then we also need an initial data structure that is built into your programming language that will be the base of our stack. So in JavaScript we have an array, so I'm going to set this equal to an array. We also need a way to keep track of how many elements are in our stack container as well as what the top element is. So I'm going to use this .top, and you can call it whatever you want. And initially there won't be any elements in our stack container, so we're going to set it equal to 0. Now we want a way to put elements into our stack container, so we'll define an add method that's going to put elements into our stack container. So we can give our add method a parameter, and you can call this whatever you want. I'm calling it element. And then we want to put that element into our stack container, so we can say this dot stack container, and since it's an array we can use square brackets to get the index of that array, and we want the element to go into the index of this .top. Since there won't be any elements in, this will be the first element in our stack, and then we want to set it equal to our element. But now if you call the add method twice, the first element that gets added will be overridden by the second element, since we're not incrementing our top property. This is still 0, so the first time our element gets added at index 0, defined over here. The second time our element gets added at index 0 again. So we want the second element to be at index 1. So we need to increment our top property. So you can say plus plus to increment our top. So let's look at what's happening. We have an add method that accepts an element, this can be anything, and then it puts that element at the index of this .top. Since our increment is after our top property, it won't increment until after the element is added into our container at the index of this .top. The first element gets added at index 0, and then our top property gets incremented by 1. The second element gets added at index 1, and our top property gets incremented to 2. Now we also want a method to remove elements from our stack, but we'll define the remove method later. So now let's define a peek method, which we're going to use to look at the top element of our stack. So we want to return a value. So we're just going to say return this dot stack container, and we want the index of this dot top. So it's grabbing the element that was added the most recently to our stack container. But since our top gets incremented by 1 every single time, so our first element gets added at index 0, but our top, which keeps track of that element, will be 1. So we will need to subtract our top over here by 1. Since JavaScript uses zero-based indexing, this element will be added at index 0, but our top property will be equal to 1 since we're incrementing. So here we want to subtract 1. Next, we want a method to clear our stack container. So we wipe it clean. So we define a clear method, and here we just want to reset our stack data structure. So we're just going to say this dot stack container, and we're going to set it equal to an empty array. We're resetting our container. We're going to do the same for our top property. We're going to set it equal to 0 since there won't be any more elements in our stack container. We also want a way to keep track of how many elements are in our stack and return that value. So we can use the amount method to return the amount of elements in our stack. So this dot top automatically tracks how many elements are in our stack, so we can just return this dot top. But we don't want to call our amount method as a method. We want to call it as a property. So we can use the get keyword to call our amount method as a property. So we're finally ready to implement our remove method. The reason I'm doing this one last is because it's a little bit more tricky. So we can define our remove method, and we want to return the value or the element that we are removing. But there is a problem. We don't want to remove anything from our stack if there is nothing to remove, if our stack is empty. So we first need to check if our stack has an element in it or not. There are several ways to do this, like using an if-else statement or using a ternary operator. We're going to use the ternary operator, which expects 3 values. The first being a conditional statement that equates to either true or false. So we're checking, is this dot top more than 0 or not? And then we need to initialize our ternary operator. The second value is what we want to happen when our first value is true. So when this dot top is more than 0, we want something to happen. We want to remove an element from our container. There are several ways to do this, but I'm going to use the splice method to remove our element from our container. And the splice method takes a few arguments, the first being the index at which we want to remove our element. And that index will be the top index, since it'll be the last element we added to our stack. But we want our top to decrease every time we call the remove method. So we need to say minus to decrement our top every time we remove an element, just like we're incrementing whenever we add an element. But there is a problem here. So the splice method will first splice from the index of this dot top, and then it will decrement. So we need to add our decrement in front of this dot top, so it decreases our top value first and then splices at the index of this dot top, since our index will be 0 and our element will be at 1, since this dot top will be equal to 1 when we increment it when we add an element. The second argument is how many elements we want to remove. We want to remove 1 element. And then finally, we need to say what happens when this dot top is not more than 0. And we don't want anything to happen. So when this dot top is not more than 0, we don't want the remove method to work, so it will return null. And that is our stack data structure, or at least a blueprint of it. If you want to initialize a new stack object, you need to instantiate it using the new keyword. So we can say const whatever equals, and we create a new object using the new keyword, and then we can use our stack blueprint. So now our whatever object is an instance of our stack blueprint. So if we say whatever dot, we have access to all of our methods and properties we defined in our stack class. Okay, now we also want to export our stack, since we want to use this as a module and we don't want to implement our stack class in the file that we're going to be using it in. So in JavaScript, we're going to say export default, and then we want to export our stack. But initially, this isn't going to work, since JavaScript uses the old syntax for importing and exporting. We need to tell JavaScript that we want to use it as a module. In order to do this, you need to use some kind of runtime, either Deno, Node, or even the browser. I'm going to use Node. So you need to have Node installed to do this, of course. So we're going to say npm init. Now this is going to ask us a few questions which I don't want to answer because I'm lazy. So we're going to add the -y flags to use the original configurations. And we press enter. And look, Harry Potter waved his magic wand and we got a package.json file. Let's look what's in here. So our package.json file is just a file of configuration settings and dependencies. So in here we want to add a new setting, which will be type. And we have two options. We can use common.js or module. Since we're not common people, we're going to use module. We're using JavaScript's ES6 module syntax. And now our stack file is a module, and we can export it from this file and import it in another file and use our stack blueprint to create a new object. So let's do that. Let's create a new file. Let's call it test.js. And in here we can import our stack from, and we need to give the path where this stack object is coming from. So we can say /, and it's coming from stack.js. So now we're importing our stack blueprint into our test.js file. So if we say const s equals new, and we say stack, we can see stack is green, which means it's a blueprint. It's a new object that we created. And if we say s dot, and we can see we have access to all of the methods that we defined in our blueprint. And so now we're going to look at some examples of our stack implementation. We're going to be using a palindrome as our first example, as it's the easiest way to show how a stack works. A palindrome is when a word is spelled the same backwards as it is forwards. So like before, we need to create a new object. We're going to call it pal equals new, and we're going to use our stack class. So I want to create a function that checks if a word is indeed a palindrome. So we're going to say const is palindrome, and it's going to accept a word argument. And then what do we want to happen? So we want to access each letter of our word. So we're going to use a for of loop to access each letter of the word we're going to pass in. So we're going to say for each letter of our word, we want to add that letter to our pal stack. So we're going to say pal dot add letter. And now we're adding each letter of our word onto our stack. So now if we remove our letters from our stack and put them in a new variable, those letters will be in reverse. Just like stacking books, if you take each book off the top and create a new stack, that new stack will be the reverse of the old stack. So since the pal.amount property keeps track of how many elements are in our stack, we don't need to use a for loop again. We can use a while loop. So we can say while pal.amount is more than 0, we want to add each letter to a new variable. So let's create our new variable. Let reversed word, and we're going to set it to an empty string. So now we're going to add each letter in our stack to our reversed word variable by saying reversed word plus equals our pal dot remove, which returns the removed letter. So now let's see if our function is working. Let's console.log our reversed word as well as our word. And to use our function, we have to call it. And I'm also going to console.log our function, even though it's not returning anything now. So which word are we going to use? Let's use code slinger. And let's see what we get. Like I said before, I'm using Node, but you can use any runtime environment for the programming language that you're using. So let's say Node test. And here we can see it worked. So this is our reversed word, this is our word, and this is our function returning undefined because we didn't specify what it should return. So our isPalindrome function is working. So now we want to say return word equals our reversed word. So this expression will evaluate to either true or false, depending on whether our word is equal to our reversed word. So let's see if CodeSlinger is a palindrome. Node test. And false, because CodeSlinger is not spelled the same backwards as it is forwards. It's not a palindrome. Let's check racecar. Racecar. And racecar is a palindrome. It's true. Okay, let's comment this out. So now let's look at a more useful use case for our stack data structure. So we're going to use factorials. So like before, we need to create our factorial object. And we want to write a function that returns our factorial calculation. So we're going to say const factorial, and it's going to accept a number as its argument. So what do we want to happen? So like before, we need a loop. But since we're not iterating over anything, we're using a number, we can just use a while loop. So we can say while our number is more than 0, we want to add our number to our FAC stack. So we'll say FAC dot add, and we'll add our number. But this will add whichever number we choose repeatedly, since that number will be more than 0. So every time we add the number, we need to decrement our number. So we add one lower number the next time our loop runs. So if we add, let's say 5 is more than 0, 5 will get added to our stack, and then 5 will get decremented. The next time, number will be 4. 4 will be more than 0, it'll be added to our stack, and then 4 will be decremented to 3, and so on until it reaches 0. So when num is 0, 0 is not more than 0, so then we'll break out of our loop. So we need a variable to put our result in. So we'll say let result equal to 1. And since factorial deals with multiplication, anything times 1 will be the same number. That's why we're using 1. So again, we can use a while loop to access our number in our stack. So we'll say while fac dot amount is more than 0, we want to multiply our result with the number in our stack. So we'll say fac dot remove, which returns whichever number we remove. Okay, so this should be our factorial. Let's see if this works. Return our result. And now we're going to console log that result by calling our factorial function. So we're going to use the number 5 to test our factorial function, and let's see if it works. And it does work. We get 120. But if you're an intermediate developer, you'd be like, well, there is such a thing as a recursive function. And with a recursive function, I can do the exact same thing in less time with fewer lines of code. And as an added bonus, it'll even be faster than our stack factorial function. And if you're a JavaScript developer, you'd be like, well, I can do you one better. I can write a single line of code that is faster than your factorial function, which together with your stack data structure is about 30 lines of code. So let's implement our recursive function. So we'll call this recursive factorial. And again, it'll take a number as its argument. And now we're going to use a ternary operator to check. So if the number is equal to 0, we want to return 1. If the number is not equal to 0, we want to return that number times whatever value we return from our factorial function, and then we'll pass in as an argument that number minus 1. And this should do the exact same thing as our factorial function. Let's check. So again, we'll use number 5. And yes, our recursive function works, and it's faster. So now you're probably thinking like, okay, hold on a minute. If our recursive function takes less time to write, has fewer lines of code, in fact, even one line of code, and it's faster, why would we use a stack implementation of our factorial? Well, to understand why, we have to look at why our recursive function is indeed faster than our stack. So every time we call a function, that function gets added to memory. A piece of memory gets allocated to our function. And that function stays in memory until the entire function has completed. So if we use our factorial function as an example, here we're calling our function, it gets added to memory. Our function runs, and as soon as we return our result, the function gets removed from memory. So in our recursive function, we call our function, and then we go into the function, but we don't return because our number is not equal to 0. Instead, we call our function again. So every time we call a function, it gets added to memory. A piece of memory gets allocated to that function. So now we have our recursive factorial function in memory twice. And that is why it's faster. Our stack factorial utilizes storage. So every time we use the add and remove method with our stack factorial function, it has to be retrieved from storage, which is slower than using just memory. But if you've been listening carefully, you've probably realized what the problem is. Our recursive factorial function gets added to memory every time. So with our 5 case over here, the recursive factorial function gets added to memory 5 times, which means at one point we're going to run out of memory if we call a too big data source. And that is why you would want to use a stack factorial function. It may be slower, but it uses less memory since our function only gets called once because our stack is not allocated in memory, it's in our storage. And every time we call our add or remove method on it, it gets retrieved from storage and then put back into storage. That's also why it's slower. This is not an either-or use case. Both of these have their advantages and disadvantages. If you know you have a lot of user data and you know you need to write a function with a loop to do something with that data, a recursive function might not be your best choice as you might run out of memory soon. So you might have to sacrifice that little bit of performance to save on memory. But it's also true that perhaps you need a little bit more performance and you know that the data you'll be working with is going to be less than the amount of memory you'll have available. So your recursive function would work without crashing your app or system. Let's look at a tiny project I made to visually show how a stack works. So here we have our amount property, which shows us how many elements are in our stack. And our top over here is actually just our peek method that is returning the top element of our stack. Currently, we can't see what that element is because our stack is empty. Here we have our add, remove, and clear functions linked to our buttons. And then we can add color to our stack, and that will just be put into a div displayed at the bottom. And notice that our top is what the color of our stack element is, and our amount returns the total amount of elements in our stack. So we can continue adding colors, and our top will update every time since our top property changes every time we add a new element. And we can also remove elements with the remove function. Notice that when we remove an element, our top property gets reset to the element that was underneath it. And our amount property also updates at the same time. And we can continue removing elements from our stack using the remove function. We can also clear an entire stack with our clear method. And this shows us exactly how a stack works. Now let's look at the code we use to make this tiny little project. And like I said before, I highly encourage you to make your own project and play around with it to learn more in depth how a stack works. So here we just have our amount and top put into H2 elements to display how many elements and what that top element is. Next, we have a main section where we have our add button and an input of type color, so we can choose a color, and our remove and clear buttons. And we also have some basic styling, nothing too fancy. And then we have our stack file. So in our JS file, notice that we're also importing our stack from our stack module that we created earlier. So we're not implementing our stack inside of our visual stack file that we're using to display our elements in our HTML folder. So like before, we need to instantiate a new object. And then over here, we're just grabbing all the elements that we need, such as the color input, our add and remove and clear button. So our stack tracker is the bulk of our logic. In here, we are grabbing our top and our length, which will display how many elements are in our stack. Our stack visualizer is the container in which we put each of our stack elements. I didn't want to call it stack container since we already used that name to define our stack container for our stack class. And then we just put all of our elements in our stack container. This stack container comes from our stack object, and we're putting it in our stack visualizer. By the way, this is very hacky code, so I wouldn't recommend doing this. But for now it's fine because our .join method doesn't mutate our stack container. It makes a copy of that stack container and then mutates that container. In our length, we return how many elements are in our colors object. Remember the amount property. And then in our top, we use our peak method to show whatever the color is of our top element. Here I'm using regex since in our element, we're adding a div in string format, and then I'm grabbing the color, which is a hex color, from that string using our regex. And at the bottom, we have our add, remove, and clear buttons. So we're adding an event to our add button saying whenever we click on our add button, we want to grab the color from our color input and put it into an element. And that element is a div. And then we're adding that element using our add function we defined earlier to our colors object. And then we also need to call our stack tracker function in here to keep track of the elements in our stack. So every time we click a button, our stack tracker will update our peak and amount properties. And then the same with our remove. If we want to remove an element, we just call the remove method on our colors stack object, and then we need to keep track every time we click the remove button. Same with the clear. We're also calling the stack tracker function in the global scope so we can keep track of our stack when we load the page. And that is basically a stack implementation. This is the first video of a series that I'll be making about data structures and later algorithms as well. If you've watched this video until now, you deserve a cookie, but you're not going to get it from me, so you'll have to go ask your mom for that cookie. But well done. Hopefully now you understand what a stack is and how to implement it in the real world. Thanks so much for watching, and please subscribe to my channel.